Welcome to Blockchain, the architecture of trust in the digital age. This video explores how decentralized systems create a new foundation for asset accounting. Our starting point is the fragility of centralized systems. Traditional client-server architecture has fundamental flaws, making it unsuitable for a global open accounting system. Level 1. The communication network, or peer-to-peer data exchange, P2P. This decentralized foundation removes reliance on a central hub, ensuring system resilience. Nodes act as both client and server. Level 2. Data structure, the immutable chain of blocks. To guarantee that transaction history cannot be changed, data is organized into a sequential chain of blocks, cryptographically linked together. Effective integrity verification relies on the Merkle tree structure. It summarizes the integrity of all transactions in a block down to a single hash value, the Merkle root, used for fast verification. Level 3. Identity and ownership, or public key cryptography. Asset ownership is proven not through a centralized registry, but through a cryptographic key pair, a private key for signing and a public key for verification. Level 4. Rules for reaching agreement, the proof of work consensus. This solves the challenge of agreeing on a single version of transaction history. Miners compete to find a nonce value through computational effort. The evolution of consensus, from energy to capital, proof of stake. Due to the high energy consumption of POW, proof of stake, POS, became dominant, where the right to create a block is determined by ownership, staking, of system assets. Level 5. Programmed value, from transactions to smart contracts. Blockchain not only records transactions, but allows executing complex business logic directly on the network. Ethereum introduced universal computation via smart contracts. The scaling challenge. Limits of monolithic architecture. Early blockchains were monolithic, requiring every node to handle execution, consensus, and data availability. Modern solutions use a modular architecture, separating these layers. The scaling engine. Zero-knowledge proofs, ZKP. ZKP is a cryptographic breakthrough that allows one party to prove a statement's truth without revealing any other information. This is the foundation for ZK rollups, enabling hyperscalability. The interoperability dilemma, cross-chain bridges and systemic risk. In a multi-chain world, the ability for blockchains to exchange data is vital. However, cross-chain bridges have become major targets, resulting in significant financial losses. Securing the future, institutional guarantees for interoperability. Protocols are strengthening security by involving trusted institutional players as validators. For example, the Wormhole Guardian network relies on major validators like Google Cloud for verification. The next frontier, decentralized autonomous organizations, DAO. Blockchain's foundation enables new forms of human coordination. DAOs are digital organizations governed collectively by members through voting on smart contracts, characterized by transparency and autonomy. The future of DAOs is autonomous, collaborative, and influential. They are moving beyond finance, experimenting with new governance models, integrating AI, and driving social and ecological impact. The architecture of trust built on blockchain forms the basis for the next generation of organizations.